Okay, so I've started laying out this problem here. You're riding your bike. Sorry, one second. Let me expand this. Okay. You're riding your bike to school with a constant acceleration to reach this final velocity of 7.5 meters per second over a time of 4.5 seconds. During the period of acceleration, the bike's displacement is 9 meters. What is the initial velocity of the bike? Okay, no. I drew my picture and I established my origin. I said, this is where I'm initially recording and looking at what's happening here, and eventually I'm going to accelerate until I get to 7.5 meters per second. That happens over a 4.5 second time span, and I got that information down. And now I got to pick an equation that doesn't have acceleration but does have velocity initial in it. This equation here, look in our summary of equations here. So we have initial, but we don't have acceleration. So that's the one that I'm working with there. Okay. And so this delta x, which is that displacement, which just means final minus initial, okay, is equal to velocity initial plus velocity final divided by 2 times by t. Now, remember, like I said, this delta x is x final minus x initial, but x initial is 0, so we could just call it x final for now. And so we have x final is equal to, the other way we have it written is 1/2 velocity final plus velocity initial times by t. Okay, exact same thing. So let's get velocity initial by itself, and we'll start by dividing 1/2 in t. So this would leave us with 2x final divided by t is equal to velocity final plus velocity initial. We'll minus that velocity final, so we're going to have 2x final divided by t minus velocity final will equal velocity initial. Okay, let's do a unit analysis. Let's see if we end up with meters per second. So this 2 is unitless. X final is in meters, time is in seconds. So we have meters per second minus by meters per second, which just gives us units of meters per second. So we're good there. All right, start plugging numbers in. So we're going to take 2 multiplied by x final, which is 19 meters, divided by time, which is 4.5 seconds. And that's going to be minus by the velocity final, which is 7.5 meters per second. Okay, 2 times 19 divided by 4.5. So that gives me 8.444, but we're going to use our 2 sig figs minus the 7.5, which only has 1 digit after the decimal place. So my final answer will have 1 digit after the decimal place, so it'll just be 0.9 meters per second. Is that? Yeah. That's my initial velocity. Okay, so we're wrapping up this unit. Let's look at one more together, and then I'm going to leave the last 2 for you to look at on your own. Okay, so a car accelerates at a constant rate from 15 meters per second to 25 meters per second while it travels a distance of 125 meters. How long does it take to reach this speed? Okay, so we have our vehicle, and we're going to get to some final destination, which is 125 meters away. I'm going to say my starting position, man, that's out of scale, is my 0 point, right? We start at 15 meters per second and we end at 25 meters per second. That happens over this distance. We're wondering how long it takes. So x initial is equal to 0. X final is equal to the 125. Velocity initial is equal to 15 meters per second. Velocity final is 25 meters per second. We don't know the acceleration, but it is accelerating, and this happens over some period of time. That's what it's saying. How long does it take to reach this speed? So that's what we're solving for, is the time. So we needed an equation that doesn't contain acceleration. Okay. All right. So here's our equation that doesn't have acceleration, so we're using that same one again. Where d is displacement, which is just delta x. So x final minus x initial is equal to 1/2 times by velocity final plus velocity initial times by t. And we're solving for time this go round, and so let's get rid of our zeros. I think that might be, yeah, our only one. It's all multiplied together. So we're going to get 2x final divided by velocity final plus velocity initial, which will equal time. And let's confirm that through a unit analysis. So we have x final, which is in meters, divided by meters per second plus meters per second. So it's just divided by meters per second. We'll put that over 1. When we divide by a fraction, the same as multiplying by the reciprocal. So our meters cancel, and we are in fact left with units of time. So that means our arrangement here is likely, very likely correct. So now let's start plugging in numbers. So we have 2 times by x final divided by velocity final plus velocity initial. Okay, so that 2 is an exact number. So when I do 2 times by the 125, I get 250, and I want it to be 3 sig figs, so I have 3 sig figs there. And then I'm dividing that by 25 plus my 15, and there's not any digits after the decimal place, so our answer is not going to have any. And then we'll divide those values. So we have 3 sig figs, 2 sig figs, so our final answer will have 2 sig figs, and so time is equal to 6.3 seconds. Okay. And actually we're moving through that pretty quick. So what we're going to do is I'm going to look at this next one, and I'll set it up for those that would like to look through that. But if you're good, then please move on to the concept check and then the assignment. Okay. Those of us that want to stay, let's just look at the setup for this one. So Molly jogs at a velocity of 2.5 meters per second. If she then accelerates at a constant negative 0.10 meter per second squared, how fast will she be jogging when she has moved 10 meters? Okay, so Molly, and she's jogging, and I'm going to say that is her initial position there. So x initial is going to be 0. X final, well, she's running to a 10 meter point. So it's 0, so 10 meters. Velocity initial is 2.5. velocity final, we're not sure of. It's saying how fast will she be jogging. So that's what we're solving for there. And then acceleration is a negative 0.10 meters per second squared. And we don't have a time component. So we're solving for velocity final. We need an equation where we can solve for velocity final, but it doesn't have a time component. So when I look at this, that one has time, that one has time, this one has time, this one does not, and it has a velocity final. So the equation that I'm going to work with is velocity final squared is equal to velocity initial squared plus 2 times by acceleration times by delta x, which is just x final minus x initial. Okay. Now, x initial is 0, and then we can take the square root on both sides. So velocity final squared will equal the square root of velocity initial squared plus 2 times by acceleration times by x final. So we want, sorry, we lost that square root when it was squared. We want to end with units of meters per second. And we're taking our initial velocity, which is meters per second, but it's squared, so our units are also squared. And we're going to add that to acceleration, which is meters per second squared, and we're multiplying that by meters. Okay, and that's on a square root, and so we have the square root of meters per second squared, meters squared per second squared plus meters squared per second squared, which is meters per second. So we do end with those final units that we're going after. So the last step that I need from you guys is just going in and plugging in those numbers. Running it in your calculator, where velocity initial is 2.5, and that's going to be squared plus 2 times by your negative acceleration there. When you plug this in, be so careful with that negative sign, meaning like please like put this in parentheses. Okay. And that's times by 10 meters. Okay, so we'll run that through. All right, guys. Good work today. Keep it up. Let's get that assignment done and turned in before the due date.